We are back here in CSE 455 Software Engineering, and we are meeting today, the 27th of April, and for the Monday meeting of this particular class. Now, let's first review on where we are in our syllabus. So let me get you there for the syllabus. Here it is. Um, we have uh, done 3 weeks of software engineering, and now here we are on the fourth week of our class, and we are continuing the requirements analysis. If you remember, we did the requirements elicitation, which is extracting or collecting from your client what are the requirements of the software. And we started the analysis last week. We will continue the requirements um, analysis plus other stuff. The SRS was due yesterday, Sunday, and I have begun reviewing them and return it to you as soon as I can for my comments. The um, the SQAP, the Software Quality Assurance Plan, and the Software Project Managed Plan will be due on Sunday, the 3rd of May. So for this particular week, I would like all the QA teams to collect the use case diagrams and the user interface designs. I want you to start building the test cases that you will try for testing the prototypes the development teams are going to produce. Now, over here on the week of the 4th of May, I'll give you a chance to revise your SRS, your SPMP, and the SQAP, depending on my review and the client's requirements. And then towards the lab, this particular week, the 27th of April, we are launching the development of prototype 1, which begins with the planning. Um, I'm planning that by this week, the requirements from the clients have all been collected and resolved, that we have tested or analyzed our requirements to be correct, complete, unambiguous, uh, and so the launching of the development is going to start for this particular week. And the 18th to the 22nd of the 7th week, the QA testing will begin testing your prototypes. If you are ready, you have the whole week, 18 to 22, to deliver your prototype 1, and QA testing will pass or fail your prototype depending on the test cases that they have developed. Okay, so that's the plan for the succeeding weeks, and I wish everyone good luck on their prototypes. Okay? All right. So moving on, we have the software quality assurance plan. I have given the format last time, but let me review a little bit about that here, where you have uh, the document for the SQAP. The most important part, as I said, the SQAP um, team, or the SQAP document, to be the guidance of the QA teams to do is the testing part, section 7. And they will be, in addition to test cases, they will be uh, 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 watching out whether you are following the um, uh, the uh, uh, the procedures and development practices that they have written in the SQAP. All right. So in this document, we will see the standards that were specified by the QA team in order to uh, make sure you are following our development process. Okay, so let me see, where is that? Okay, uh, this one here. Okay, so in the sample SQAP document that I've shown you last time, here are the um, let me go down some more. Development practices. Oh, these are the testing that the QA team will be specifying. And for each prototype, let us say here, SOS, uh, they will test for each use case that you have in your SRS. They will have a sequence of UI relating to that particular use case. As I have told you before, a use case may have one or more user interface. So your test case will have to be based on the user interface design. And um, and that's the reason why I'm asking the QA teams to collect all the use case diagrams and all the UI designs that they have for each of the use case they have in the use case diagram. I will show you examples of those, and um, the QA team will have to determine as early as now test cases to use to test those use case using the user interface. Okay, um, and also the following are the by the way, the QA team is free to design a format of their test results for each particular team. So I want to see the test case description. What did they use for as test case? for which use case and the use case that you are testing here, you will specify test cases of the user interface that you have tested in relation to that specific use case. Okay, and notice here that they will also test whether you have followed the standard code compliance. And I would like to add in the report compliance with, or have you satisfied the non-functional requirements. Remember, we are testing not only the functional requirements, we are also testing non-functional requirements such as performance, usability, maintainability, security, and so on and so forth. Okay? Okay. The part that I would like you to pay attention, especially the QA, are the, let me see here, the development practices, section 5.2. Here, they are specifying whether you're supposed to be knowledgeable about the repository you are using, that you should commit often, add useful detailed messages to each commit, follow coding standard provided by the QA. I would like to add whether each team is doing unit testing, integration testing, and system testing. Unit testing, as I have discussed before, refers to each individual software engineer to test their own code. After they finish a segment or a function or a class, they should test their own code for presence of errors. Once you begin integrating your source code with another member of the team, then you should again test the integrated source code. This is called integration testing. So we'd like the QA team must see if you have documentation about your testing practices. And after that, if a module or component is formed after integrating with other modules as well, and you come up with a complete system in your development, that system or the prototype itself, after you producing it, you do the system testing. So in addition to what the QA team is doing, which is acceptance testing, the team is responsible, development team is responsible for unit testing, integration testing, and system testing. Another testing that you should also do, the development team, is to test for regression. It's called regression testing. And regression testing is testing done to the use case that were existing before you develop additional functions or additional use cases into the software. Remember, if you are continuing this project, you are adding use cases or you are fixing existing use cases. So you don't only test the additional use case or fixing erroneous use case, you are also testing whether the previous use case are still working. That's what you call regression testing. See if the rest of the software is still functioning correctly. So unit testing, integration testing, system testing, and regression testing should be practiced by every development team. The QA team will inspect or um, see evidence that this testing is being done by the development team. Remember that, okay? So that's the responsibility of the QA team with regards to testing, okay? All right. Let me get out of here and move on to the requirements analysis. We began looking at previous examples of requirements analysis. So after you have extracted the use case and the corresponding user interface for each use case, we must determine whether the requirements you have elicited are correct, complete, consistent, and unambiguous. We have to find that out because if it is not correct, then your software will be wrong. If it is not complete, that means there are missing use case that you did not consider. If it is not consistent, then you have not extracted the correct the requirements of the client. It is not consistent with the requirements of the client. And if it is unambiguous, then we will have trouble developing this. If it is ambiguous, we have trouble developing the software correctly. Okay? So the software engineer must validate, correct, and clarify that the requirement specs are free of any error or ambiguities. So that's your responsibility. So after collecting all the use case and designing the user interfaces for each of the use cases, you have to validate them, correct them, and clarify it. And how do we do this? We use UML diagrams to find out how the actors manipulate the application domain through the user interface. So this UML diagramming is very, very important. It's a very important tool in our analysis. And the advantage of doing requirements analysis, your requirements analysis will lead to the software architecture design. Okay? Some of you are raring to code, but we're not ready to code yet until you understand the whole structure of what we are supposed to do. And so coding, as you will see here in software engineering, is a part of a large software process that we are following. Okay? So coding is just one phase in the software life cycle. Before we can code, we must understand what the client wants, how we're going to, what are the functions that we need to implement, both functional and non-functional, and we need to design. So we have a structure or a blueprint of how the whole software will be put together. Then, and until then, you will begin to code. Okay? So we have a long process to go before we can code. Okay? All right. So let me kind of go back to our initial example. Okay, I lost again my cursor. Sorry about that. And let me uh, click on this so we get to all the UML diagrams that we have been studying. Okay, so uh, here in this example, let me see the diagrams. All right, so here is our process of determining non-functional and functional requirements. Now we're going to the analysis where we use UML dynamic models and object models to help us in the analysis. And the advantage of doing this modeling, we will be able to derive the system design and the object design. So it pays to go through the analysis to derive the design, because the design doesn't come out from thin air. Design comes from analysis. Remember that. Okay? And we have looked at this emergency system with the field officer and the dispatcher, and we're just looking on one use case: report emergency. That's just one use case that we are analyzing. So the field officer um, uh, used the emergency system to report emergency. The dispatcher reads the report emergency and interact with the field officer through the report emergency. So we are just analyzing report emergency use case only in this lecture. Okay, you will have another analysis for opening incident and another analysis for allocating resources. Okay, so what we are going to discuss is just reporting emergency use case. Okay, and if you remember last time, we we look at the interaction of the field officer when the field officer um, was called to an emergency situation. And this is the sequence diagram for the report emergency use case only. Okay, you will have a separate analysis for the other use cases. All right. So from last time, we said the field officer press a button on uh, on the window or the user interface of the report emergency button. So this is a user interface for reporting emergency. So we see on the screen of the patrol car a user interface to actually start the report emergency use case. It creates an object called report emergency control. So this object here handles the request for emergency form, and the report emergency form creates the report emergency form. So from the control, it generates the report emergency form. So report emergency control, when you translate the sequence diagram into a software architecture and design, report emergency could be a class or a module that handles the request from the field officer to create or to show the report emergency form. So the report emergency form is displayed. The field officer fills up the contents. After some time, the field officer submits the report, and the submitting the report some kind of an acknowledgement that the submit report was detected by the report emergency control object. It then creates the emergency report. So this is an output of the user interface. And the whole thing is submitted to the dispatcher right here. So manage emergency control is an object that handles receipt of emergency control. And notice here, this object here, emergency report emergency control, destroys the form. So the user interface is gone. It's removed from the system. But the result of this sequence diagram or interaction is a submission of a report to the dispatcher, okay, by the managed emergency control. Here, again, you identified an object, which could be a class or could be a module or a package that handles that. Okay, so let's look at the side of the dispatcher. So the submit report dispatcher is received by the managed emergency control. Going back, so remember that managed emergency control receives the report. So what happens after that? So this is what happens. The managed emergency control creates an incident form. So what is the incident form? Incident form is a user interface. So this is a form that the dispatcher use for entering information about the incident. Okay, so the incident form was created upon the receipt of the report from the field officer, and at some time later, the dispatcher will create the incident. It will create an object called incident. The dispatcher will submit the incident report after it is done. It will create an acknowledgement. And after that, managed emergency control destroys the incident form. So we have identified three user interface right here. The report emergency button, the report emergency form, the incident form. So those are three user interface just for the use case report emergency. So as I have told you, every use case may have one or more user interface, and you focus on testing the user interface. Okay? All right. You have the manage emergency control, destroys incident form, and now we create acknowledgement. Where do you think acknowledgement is going to go? Acknowledgement is going to be sent to the field officer, telling the field officer, hey, we got your report and we're handling it. So that's the next sequence of actions that happen. The field officer was informed. Okay, so remember, the acknowledgement notice was sent. The acknowledgement notice in the previous diagram, acknowledgement is an object that was created by the dispatcher, and the managed control system receives that. So the acknowledgement report was received by the managed emergency control. Okay, so that's an object that handles all emergency control, and the report emergency control it creates the acknowledgement notice, and end report transaction. It must end when the transaction is over. The acknowledgement notice was sent, so the uh, the field officer knows that the report was accepted. So it dismissed the acknowledgement notice and the report, and then the managed emergency control system destroys the report emergency control. So report emergency control is created for every emergency that is occurring, and managed emergency control is for managing all incidents reported by field officers um, in the field. Okay, so that's the analysis for the um, uh, emergency system. So reiterating, let me again uh, emphasize the fact the sequence diagram you have seen is report emergency only use case, and we have identified several user interface for the report emergency. We have identified uh, the report emergency button user interface, the report emergency form is another user interface, the incident form is another user interface. And you might say the acknowledgement is received, it's an input to a user interface that the field officer receives after submitting the report, incident report that was created by the dispatcher. Okay, so that's just one use case. You will do the same thing for the other use cases as well. Analyze it, make sure you understood everything about this use case, what are the user interfaces, and the reward you get by doing sequence analysis, requirements analysis, is that you will identify important classes, modules, or packages that you will need to structure your software design. Okay, so I would give as an extra point for all those development teams who will include at least one requirements analysis in your SRS. Okay, so I'm giving a challenge to every development team to add in your appendix a sequence analysis or a requirements analysis using sequence diagram, UML sequence diagram in your SRS. Okay, this is an important part of the software requirement specification. As I have said, the first phase of the software lifecycle is the most important part of software development. If you don't get right the SRS at the beginning of your software lifecycle, none of the succeeding phases will be correct, right? If the first step is wrong, why do you expect the rest will be correct? Okay? You cannot derive a working software if the specification is wrong or incomplete. Okay? So I give that as a challenge to every development team to include at least one use case analysis and identify the interface, user interface that will be needed by that use case. Understood? Okay. Although I don't see your faces, I would consider that as a as an affirmative. All right. Okay. So let me um, go to another example so that you will be able to do your SRS correctly. Let me go back to another use case, example use case diagram that we have done before. Let me see if I can find it. I think it is this one. Okay. Remember last week we talked about this what we call a tournament, um, application for managing small games like tic-tac-toe or chess game. Okay, so here we are just looking at one actor, the league owner, and how to sponsor a tic-tac-toe beginners league. So we're just looking at one use case, and the actor is Joe, or league owner. How does the league owner use the system for sponsoring a tic-tac-toe beginners league? Remember that? Okay. So let's look at the requirements analysis that was done for that. Okay. Okay, I think this is the one. Okay. So how to sponsor a tic-tac-toe beginners league. Okay. Here it is. Okay. So use case diagram for announcement of a tournament. It's kind of a, how do you create a tournament? So the league owner, there is a tournament form that the league owner needs to fill up to start a beginner's tic-tac-toe tournament. So here you identify a user interface that is required or that is needed by the how to sponsor a tic-tac-toe tournament. So the league owner fills it up, and what happens at some time later, it creates an announced tournament control. Now, announced tournament control is an object that handles the creation of new tournaments. So that that entity that you see there is an object. It is not a user interface. It is an object that handles messages um, and handles the request of that message. So that is an object that could be a class, a component, a module, or a package in your software design. Okay, so what it will do is check the tournament, see if there is if there is one that's existing, and here is an object that actually is a search. Find out if there is already one that is that was created. Okay. In the meantime, excuse me, the league owner set the name. So the league owner is inputting parameters to the tournament of tic-tac-toe, set the maximum players, and then at the last step, commits. That means it is created. The arena here, maybe it should return an acknowledgement or a result of checking the maximum tournament that we already have. And after the league owner commit the form, it creates the tournament with the name of the tournament and maximum players. It then creates a tournament with name and maximum players to the league. Okay? So the arena checks maximum tournament, and the league actually creates, after it receives the request for a creation of a tournament with name and maximum players, an object called tournament. So you see, the league owner has submitted this sequence diagram that you see over here is just for a request to create a tournament for tic-tac-toe. Okay. So what happens next is the league owner will have to arrange for a sponsorship. Who will sponsor the tic-tac-toe beginners game? So it will have to request exclusive sponsor. To the request is sponsorship form. So notice here, again, it's a form. So that is another user interface involved in the league owner sponsoring a tournament. So that's the second user interface that is needed for that use case. Okay, and it will request an exclusive control sponsorship here in the announced tournament control. So announced tournament control is an object that manages the control of the tournament, exclusive sponsor, and then later finds are there anyone interested in sponsoring? So that's the arena. So announced tournament control, tournament, arena are object. They are modules, package, or components of your software. At some time later, there could be a confirmation of a sponsor. Somebody replied to the announced tournament control, hey, I'm interested. And so it confirms through a sponsorship request, another object that notifies the sponsor, who is an advertiser, hey, I'm willing to sponsor this tic-tac-toe game. Okay, so that's nice. And then it will reply yes or no, right here, yes or no. And that is passed on to the sponsorship reply. So sponsorship reply is created. So this is an object that was created for the purpose of replying to the sponsorship, to the sponsor who is interested, notify the league owner. Then the league owner performs a select the sponsor. So this symbol here symbolize a processing that is done within the league owner object or actor. So it will probably record the sponsor. There could be several sponsors. Then there should be a kind of a set the sponsorship, who are those advertisers who are accepted as sponsor, informs the request, inputs to the request sponsorship form, the set sponsorship. So that's an input to the to the user interface, request information, request a sponsorship form, set a sponsorship, sponsor informs the announce tournament control, and announce the sponsorship to the tournament. And that's the end of this part of the sponsorship um, uh, uh, sub-function of uh, sponsoring a tournament. All right. So here in the announce tournament use case, so what we do now is we have to inform the players, right? So the league owner notifies sponsor. They say, hey, there's somebody who would like to sponsor the uh, the tournament, and so notify interest groups form is another user interface. So we have identified another user interface for this use case. Okay. And notify sponsorship decision to the announced tournament control, which creates a sponsor notice. Okay, so at some time point later, the advertiser will be notified, hey, we accept your sponsorship, or no, we are we are not accepting your sponsorship or advertisement of this for this particular game. So he has to be notified, yes or no. And next, the league owner has to notify the interest group. Remember, the interest group who wants to play tic-tac-toe must be informed that the game is a go, and we have many sponsors. So here we notify interest group in the announced tournament control. So here we notify the groups. Here we announce tournament control. And here we announce notify interest group to the interest group. Okay, creates interest group notice. And the last step is notify the players right here. Okay, so that's the sequence diagram used for analysis. And during the course of the analysis, you identify user interface and objects that you will need in your software architecture. Let's move on from the requirements analysis to the next part of the lecture today, and like to introduce software project management plan. This is another um, document that is needed to actually plan on what's going to happen in the next few weeks. As you know, this fourth week, we are launching the development of prototype number 1. And on the 7th week, we will deliver prototype number 1, or the first iteration of your project. So I'd like you to start writing this software project management plan. I'd like to specify that the software project management plan is the responsibility of the project manager and the assistant project manager only. So these are the two uh, personnel who will be required to write the software project management plan. Okay, so make sure you plan on submitting this document. The first version will be required to submit by the 3rd of May, which is the Sunday of this particular week. It is a document that will be used by the whole team on how to um, complete the first iteration by the 7th week. What are the events and things or milestones that will be happening between now, this 4th week, up to the 7th week? Okay, let's look at the format of the SPMP. As you all know, we are following the IEEE standard, and there is an IEEE standard for a software project management plan. So this will be a software process on how to write this document. There are many sections of the SPMP, and the first one is section 1 is the overview of the document. We begin by a project summary of what is the purpose, scope, and objectives of this project, and what are the assumptions and any constraints. What are the project deliverables? Our project deliverables are all the documents we are producing, plus the source code, plus the software design, plus the testing reports that we are producing, and we'll put that in a repository for the next team to take over or continue your project. The next section is the schedule and budget summary, and this is just a statement that the 7th week is our delivery of the first iteration, and the finals week will be the delivery of the second iteration. And that's just a summary, and I'd like to reiterate that the purpose of the software project management plan is to estimate the time and budget of the whole project. In a software company, these are the bottom lines of any planning. What's the budget, and how and when do you expect to deliver? Of course, in our virtual software company, our delivery is the finals week. We cannot specify any other deadline than the finals week. And also, there is no budget involved in this software project that we are undertaking, but the budget is the most important output of the SPMP. How much will it cost to produce the software? And the budget is 99.9% salaries of software engineers and everyone who is involved in the project. That's the budget. And as you have, as I have told you, a master's student in software engineering, if you undergo that Carnegie Mellon University master's in software engineering, your salary is 105 to 110,000 a year. So you can just imagine the budget that will be involved if it is a large project consisting of many software engineers. Okay? Evolution of the plan. How did this plan evolve? So kind of a history of what is involved in the evolution of this plan. It is, of course, our software company called CSE 455 Inc. How did you come up with this plan? References. All the documents that are used in, in producing this document are put here. Any definitions, again, acronyms, um, abbreviations that you have used. The project organization. So the project organization consists of diagrams of who is dealing with the external world. The external world is the client and the maybe other consultants that is you're getting information from. But who deals with the client? Who talks to the client in your team? Internal structure is the structure of your own team. I have already talked to other teams about having two sub-teams because the client wants an iOS and an Android implementation. So the structure is a sub-team for each of these platforms. Now, this is one of the most important part of the SPMP. Who is doing what? So you list all the members of your team from the project manager and assistant project manager up to the last software engineer in your team. And I want to see what are the roles played by each member of the team. And they will be held responsible for these roles and duties if they fail to come up with with their responsibility, accomplishment of their responsibility. So the managerial process, remember, software engineering consists of project management. So this is important in terms of management. How are you managing the team? And that is why the SPMP is the responsibility of the project manager and the assistant project management, assistant project manager. So what is the startup plan? When did you start? What is your estimation? How do you estimate the cost? Staffing, where did you get your people? Of course, in our software, virtual software company, the staff is coming from people, students who enrolled in this class. They are automatically members of the software development and the QA development. Resource acquisition plan, some of you requested for MacBooks, so or Mac computers. So how are those acquired? And the project staff training, are there any training that you went through? Well, I prepared the class in terms of how to write different documents and how to carry out the software development. The work plan, what are your work activities? Your work activities refer to the production of the different work units. And how do we define work units? Work units consist of documents, design in UML diagram, and source code, and other output that is involved in your development. Schedule allocation. I want to see in your schedule allocation a Gantt chart, Gantt, Gantt, that shows the different activities that you're going to plan for the next 3 weeks. Remember, 7th week is when you will deliver your first iterations. I want to see a specific date, month date on what will happen in the next 3 weeks. Resource allocation. How are you allocating resources? And resources are computers, of course, that you will need. Now, budget allocation, we don't have a budget, so you may skip this part. But if you have one, then you have to specify the budget. We don't want a budget that is under budget, which is very rare that's happening. Most often, the budget is over the estimation. And it's also very rare that it will happen. You have the exact budget uh, that you will use. Okay, so that's kind of a um, uh, uh, the budget is I said, as I have said, most important part of the SPMP. Control plan. Who are you controlling? How are you controlling the requirement? Supposing the client in the middle of your development says, hey, I want to add this, or I change my mind. I don't want uh, that function. How are you going to accommodate the change of requirement? Schedule control plan. Uh, if there are situations like the coronavirus that we are having now, when everything is locked down, so how will that affect your schedule if everybody will be working remotely? But one of the most important part of software development is getting together and interacting with each other to control or carry out the development process. Who is handling budget if we are over budget? How do we do that? Or we underestimated our budget. How do we ask for extra budget? Quality control. Quality control is the quality of the code that you produce. How we're going to control that in terms of I mentioned before, the quality of your source code depends on the density of error per 1,000 lines of code. How is reporting plan happening? SQAP generates a report, and how is that report, testing report, is being handled? Metrics. An engineer always use metrics in terms of output and what needs to be done in the improvement of the process. Risk. Risk management is a very important part of project management. There must be a way to identify risks, what could happen, and how to mitigate the risk. The important thing is to identify the risk now and then mitigate and have a plan to how to mitigate. Closeout plan. How are we going to close out our project? Who is going to make sure that the repository is up to date and you have all the outputs that we have produced in our development is kept in a safe repository, and so another team continuing after you will have the complete documentation, software design, source code, everything. They are called software artifacts of the project, which will be important in maintaining the software to the next stage. Okay, technical process plan. What is the software development that you are using? If well, I mentioned we're going to adopt agile software development process, so we're going to adapt that, and there are many agile software development and that is out there. There is Scrum, there is extreme programming, there is micro waterfall model, there is spiral model, many other uh, uh, the same category as the agile methodology. So adapt one. So management team, project manager, assistant project manager, adapt a particular process model and use that in your team. Methods, tools, and techniques. Of course, we are following the object-oriented paradigm, and we are using tools that are allow us to use object orientation. Infrastructure plan, if you have any, that should be um, included. Supporting process plan, configuration management plan. We use repository on how to store all our software artifacts. Verification and validation plans are plans that you like to ensure that we are following. Documentation plan, quality assurance plan, reviews and audits, problem resolution, and subcontractor management plan if you are outsourcing part of the software outside of our company. All right, and additional plans, annexes, and indices. So I will end here of my lecture. So this is as I said, SPMP is the responsibility of the project manager and the assistant project manager to write. And I am next meeting. I'm going to show you an example of an SPMP, and how to write one. Okay. All right. I'm ending my lecture for today, Monday. So be safe and healthy.